It's about to start, we'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is actually something very exciting. We are working on a library to help you develop real-time audio effects in REAPER. And we have started using this library in a couple effects, the first of which was a waveform display. Let's bring it in. It looks like this, and it just renders the audio coming through. Pretty straightforward stuff. And the whole point of the library is to make audio effects that help you see what's going on. So if an audio effect is a compressor, you would see the gain reduction on the waveform, and you would see how it affects the waveform. And then we built this component that shows the waveform, and it was a pain to develop. We worked on this for months on end. It's a simple component, but we decided to do it right, and that was a lot of work. We worked on several strategies that didn't pan out. In any case, we have it now, and this effect is mostly a display of what the component looks like. But for the first time, we are going to use the component in an audio effect that does something beyond just visualization. So it really is the library coming to fruition. It is the first time we are going to be using the library with the vision of the library taking place. So I'm very excited about this. The effect that we are working on right now is an Automixer. It's a kind of effect that helps you on mixing and editing podcasts or roundtable interviews, and sometimes even on live settings. You would put an Automixer where you have multiple microphones open in a room, perhaps a roundtable situation, and you would like to prevent bleed from one microphone or from one person when they speak, that kind of cross the bleed that happens from one person speaking into someone else's microphone. That's what I'm saying. And an Automixer helps with that. And the way that it works is it allocates different gain to different microphones on the fly. And the gain depends on how much the microphone is picking up signal. In any case, we are not too concerned with the algorithm of the Automixer. We are more concerned with the visualization. So the Automixer is going to and it's never going to increase the level of a microphone. It's only ever going to attenuate. So the vision I have is to plot two waveforms, one on top of the other. And the one on the back is the original waveform coming in. And the one in the front is going to be the produced waveform, the waveform with the attenuation. So it's going to look similar to something like relimit. If I make the attenuation really drastic here, it's going to look something like this, where in light gray on the background, you can see the original waveform coming in, and I made this threshold so large that it is kind of clipping the whole time. Anyway, now it's better. So the light gray is the original waveform coming in, and the dark, I guess perhaps black, is the output waveform after the limiter. And then this is the gain reduction. And I would like the Automixer to produce a visualization very similar to this one, if not exactly the same. So we already have the components to draw the two waveforms, and we are going to be using the component in the effect. And I think it's going to glitch ever so slightly. And then we'll probably try to address that, or maybe we'll just let it glitch depending on how bad the glitch is. And if it's too bad, then maybe we will address it. But if it's kind of okay, we'll try to do this stop scrolling thing, which is the gain reduction. So let's dive in. I have here the code for the effect that you saw first. It's this effect. And it's doing a couple things that we want to do on the Automixer, and it's also doing a couple things that we don't want to do in the Automixer. We actually want to do things, the drawing will be a bit different, and we are not concerned with things like zooming and whatnot. I think that the view should be fixed. For instance, here on Real Image, you cannot zoom. I guess you can resize, but you cannot zoom. So we'll stick to this kind of vision that is relatively straightforward to implement with the library we have at this point. So let's go over the code for the waveform and see how we can adapt stuff for the Automixer. Well, I guess first of all is the waveform component itself, and we will need one waveform component per channel. So in this case, I have a stereo signal coming through, and I don't know what Real Image is doing. I don't know if it's adding up both channels or if it's just looking at one of them. Not really sure. In our case, I think it makes sense. Well, I was gonna say makes sense to show the waveforms for each channel separately. But it may also make sense to just add all the channels together. I think I'm gonna do separate channels. So oops, bumped into the microphone. So it looks more like the kind of thing you would see on the timeline. Yeah, though to be honest, most use cases for an Automixer are with mono microphones. So perhaps it does make sense to see the waveform of the channels already combined. I don't know. I guess I'm gonna do one per channel because it is the most sophisticated thing. And if we decide to dial it back, it's relatively straightforward. Just don't have one waveform component per channel. We'll actually need two, one for the input, one for the output. So let's go to the init section on the Automixer, and I guess I'll leave this last in the code because it has to do with visualization, and I'll leave here first in this section stuff that has to do with actual processing of sound. So this is the waveforms inputs. But we'll also have outputs. And we also have to think about what is the length of audio we want to store. In the little component that is this effect, this is actually a variable. But in our Automixer, we'll have a fixed number. So I think we are going to do something like 3 seconds. I think it's a good enough window. Then let's return to the waveform display. Well, this has to do with something that the Automixer currently does not do, which is the number of channels that should be taken in account. Currently, we are always taking in account all the channels. So we can skip this part. And this is just about sliders. We can skip that. We can skip this too. I think that this is already in place. So let's move on to the sample section. And this is where audio is coming into the plugin. We need to store the samples so that the waveform display can show them in the user interface. So we will be storing samples. We will be doing this reset and this push stuff. And I will be doing this at the end. No, I guess I will be doing this in the beginning because I will work with the inputs first. So it will be like store stuff from the inputs and then process, and then at the end, store stuff from the outputs. As simple as that. And Ben is here. Hello, Ben. It's great to have you here. I hope you enjoyed this session. So let's review what's happening here, because we dealt with issues that have to do with the plugin being bypassed so no audio is coming through, or the plugin not showing, so you have the interface for the plugin closed, and in that case you don't want to waste resources by storing samples on things that are not even on the screen. So we did a lot of work on that. Let's review what we have here and see if we see what we want to keep. So if you are just starting, you were bypassed. So the plugin was bypassed. No audio was coming through. And now audio is coming through again. We are about to start displaying the waveform. So in that case, we want to reset the waveform display. Similarly, if the user interface was closed, we were not collecting samples to save CPU. So we need to reset the waveform display to start showing samples again. And this is something that you can decide on in the waveform display thing, this little effect. You can decide to reset on playback. So when you hit play, it resets. And this is something that is off now. And if I turn it on, then you can see that the waveform display restarts. In Relimit, that's an option as well. Clear display when playback starts. So in theory, I could give this option to the user, but I am going to make the decision for the user. I don't really love how these kinds of plugins give you these kinds of options. And yes, it's hidden under the context menu on the right click of the mouse. So it's not terrible, but I want to design the effect as I think it should look and have as few options as possible. And if people start asking for this, then maybe I will introduce it. And on this one, I think it makes sense to have this as an option because I wanted to have this in the library, and this is like a showcase for the library, but also in this case, you may want to customize because it's about visualization, but the Automixer is not about visualization. So let's cut back on options and just decide what we want. I don't want to restart on playback. I don't want to reset on playback. So I just delete the condition. And then here, where it says waveforms, it needs to be the inputs, right? Because that's what we're collecting. Then, only if the user interface is open, we are going to be pushing samples into the waveform components. Great, I think that that's all we need. Now we are going to rinse and repeat for the outputs. And let's take a moment to appreciate, if this works, let's take a moment to appreciate how straightforward this is for a programmer using the library. It's the kind of visualization that I think is pretty cool, very useful too, and it's relatively straightforward to implement. So that's good. Okay, so all of this was to collect the samples into the waveform displays. Now we need to actually display this stuff. So all of this is to deal with the user interaction. We played around with the concept of being able to drag and drop to control the zoom. In our case, we don't need any kind of interaction. A real limit, for instance, doesn't do anything. So we don't need that right now. So I can skip this. But this is important. So let's get, well, I was going to get all of it, but it's a lot. So let's just get this. And that's because I only want to draw the user interface if there are samples coming in, if audio is going through the effect, if it's not bypassed. If it is, then notice how I can skip this whole block, effectively doing nothing. And that saves on resources as well, I think. Well, not really, it doesn't save on resources, but at least it doesn't show stale data because the plugin is bypassed, so it doesn't render a stale graphic with old samples. Right, so this is something we want to do. It's just to reset the background color. And let's not deal with embedding. So at this point, for this plugin, the intent was that you would embed it on the MCP, so you would show up like this, and it's perfect for this kind of plugin. But for the Automixer, I think that for now, let's not deal with that. This is still keyboard or mouse interaction stuff. And this has to do with the positioning of the waveform, and this is something that we probably want to get. Oh, and does relimit have any kind of grid lines? It does not. And perhaps we won't either. We do have the notion of grid lines, and when I say grid lines, I mean something like this, showing time on the x-axis and showing the dB on the y-axis. And I guess this is so small that we don't even get to see it, but there is a way to set some grid lines that are horizontal. But let's not deal with that right now, which means that we don't need all of this code. I'm thinking if I should do this whole channel stuff right now. Yeah, let's bite the bullet and do it. It's not too difficult anyway. So let's get this whole loop. And this is just instructions, so we can skip that. And let's adapt the code that we copy and pasted. So first of all, let's keep these variables. They are setting the x and y coordinates for each of the waveform displays, and because we have multiple channels, we are going to stack the channels one below the other. All right, see you later, Ben. And this channels variable is for us the number of channels, because we are not dealing with only plotting the first channel. If a track is stereo, only plotting the first channel, for instance, we are not dealing with that. So we are hard coding this, which is the number of channels in the track given to us by REAPER. And the width, oh, this whole vertical thing, let's not do any of that. This is in this. If you want to embed it on the MCP and everything, you can give it a vertical orientation. We are not doing that in the Automixer. Let's find other places where we do this vertical stuff. Oh, and I am missing. No, I'm not. I thought I was missing this line, but I'm not. Okay. So what's up next? This JSFX width. That's not what I want. Hey, Bo. Great to see you here. I hope you're feeling well, and I hope you are as excited as I am for using a graphical component of the library for its original intent, which is to show what an audio effect is doing to the audio. That's what I wanted to do in the first place, and it has been almost 1 year, and we are finally gonna get to do it. Okay, so this width and height are variables on this. It was a bunch of variables on the waveform display, but in the Automixer, I want to have fixed values. I don't necessarily want to deal with this situation that we have in ReLimit, where you can resize, because I don't think it's gonna work all that well for us. Let's see. If I have the waveform display on the TCP, it's easy for me to resize it. And let's see what it looks like when it is resizing. Oh, it actually works pretty well. Yeah. It actually works pretty well right off the bat. Okay. Good on us. So let's deal with this issue right away. And let's make it resizable, because why not? So this is the GFX width and GFX height. And these are variables given to us by REAPER. That's why they use the underscore and the abbreviations instead of using dots and full names. When you see dots and long names, that's us. That's the library, or that's me writing an effect. Anyhow, so then we have the function that actually draws stuff. And we want to draw the inputs first because it's going to be behind, and the outputs second because it's going to be in front. So let's do inputs. And then there is this, what's GFX? I think that in our case, this is just 0 for now. And same with this one. We are probably gonna change this because we are probably gonna have some knobs in the user interface. So right now we are drawing the waveform across the whole user interface, but I think we're going to use some knobs and then we'll need to occupy less space. But anyway, this will do for now. That seems about right. And then the zoom, we need to remember what are the defaults. I think that the default zoom is 1. So I think that we should go into the library and get something like scale 100, like so. The duration in milliseconds, oh, it's already in milliseconds. I don't need to convert it to samples. So the duration in milliseconds, let's have the same duration as the component itself, so 3000. I think we are able to use 3000. We may need to use like 2999, I forget. Anyway, square root, false, vertical, false. And as for the color, we are not giving the user options, we are designing this thing. The color will be some sort of gray, and I think we are using the gray warm scale, so let's go with that. But let's pick a dark gray because it's almost part of the background. So it's going to be like 700 or something. As for the opacity, it will be completely opaque. The grid, undefined. It seems like I need to pass undefined for the grid. Then for the grid color, it can be undefined as well. Just like this. Let's find the waveform. draw function. Let's find that. So now next is opacity. So it can probably it can be undefined as well. So that's that. Now let's rinse and repeat for the outputs. And this time I want a lighter color so it stands out. Something like this. All right, moment of truth. Perhaps this is gonna draw something. And to make this actually interesting, I will have a second track where I will load a tone generator. And that's just so I have two things going on, so that the Automixer is actually bringing the volume down. And something around this will do. All right, let's bring it in. Automixer development. And we are getting some good silence here. Oh boy, didn't work. Well, at least the effect is still working. It hasn't broken without me touching it. It happens sometimes. It's called code rot. Code can rot, but it didn't happen this time. So we still see attenuation going when I start speaking. So the tone generator is making space for my voice. Great. But I don't see anything on the screen. It's not plotting anything. Well, let's figure out why. Let's first review the changes because we're going to start debugging stuff. Oh, I think I already know the issue. It's the use of these channels variables. Yeah, let's replace some occurrences of channels with num ship. Just like that, and try again. All right, there is some audio going through. Nice. And if I put it on the tone generator, then it is perhaps too faint. So maybe I need to zoom or something. I don't know. But I can see, and perhaps the colors aren't that great because it's too washed out, but I can see the attenuation happening. Perhaps it will be clearer over here on the sine wave. Yeah, all of this is very, very small. And if I put real image on the same track, it's about the same. So it's actually almost exactly the same by chance, of course. So perhaps this is good enough, but I don't love it. Well, let's fix the colors first. 700 is not good enough. Oh, let's commit and then fix the colors. But at least we have something on the screen. Very exciting. I think I'm going to go with 500 and 200. It would be very bright, but I think it will do. All right. Now it's more like what I wanted to see. Let's see this other instance. Hello. All right. Yeah. Well, it's showing attenuation. All right. Not bad. It's still too small though, it's a bit too narrow. Should I use square root? But that can be a bit misleading, I think. And why is relimit no longer bouncing up and down? Because it's before the Automixer. All right. Perhaps 3 seconds is too much. What if we do 2 seconds? Well, I don't know. Let's see how much relimit does. It does. It's more like 6 seconds or something. So I guess 3 seconds is okay. What could I do to make this more interesting? I could zoom. I could take the square root. What do you all think? What should I do? Tail is here. Hello, Tail. It's great to have you here. What do you think? What do you think we should do? Right now, what we have on the screen is the inputs in light gray, the outputs in blue, in brighter white, lighter gray actually, but almost white. And it doesn't look too great because it's too narrow, it's too thin. So I could zoom into the waveform, I could take the square root, which makes everything bigger. But do you have a preference? I will actually try a couple options and we'll see. Perhaps you could rectify, because if you look at other plugins that are not relimit, if you look at like the Fab filter compressor, it rectifies the display. You could try that. Let's start with the square root, because it's so easy. Just have to remember what is the argument. It's right after the duration. Okay. I have to put 2 Automixers to actually see the thing bouncing up and down, and now we see more stuff. Yeah, we see stuff happening. It's better. I think I like it better. And let's see the sine wave. Yeah, that's pretty okay. It's actually pretty good. Perhaps just black and white isn't too attractive. We could put some colors in here. But the spirit of it, I think I like it. Yeah, I'll keep the square root for now. And I could zoom. I could try to zoom. But I tried square root first, and I am hesitating to try zoom because it may seem like you're clipping the waveform when you really are not. It's just a display. So I don't know. I'm not feeling it. And what about the grid lines? Well, I will leave them for later. Grid lines. Zoom question mark? I don't know. Not sure, but maybe you could display the RMS instead of the waveform. That way it's already rectified. But yeah, this already looks fine. Yeah, well, I'm glad you liked it. And I am planning on displaying the RMS. You are absolutely right. In fact, I am planning on doing something similar to what relimit does. Why is nothing showing up here? Come on, relimit. Oh yeah, right. So if I put the relimit way down, you start to see gain reduction, and that's what we are going to do as well. Oh, and it even reacts to the amount of gain reduction that is happening. The scale adapts so that it takes this much space. That's very clever. I don't think we are doing anything clever like that. And it doesn't scale back So if you happen to do a lot of gain reduction all at once, then you're stuck with some weird shape at the top. Then that's a bit silly. Okay, but if you start playback, then it resets itself. Anyway, I don't think we are doing any auto scaling like that. It's a bit fancy and I like it, but let's not do it right now. But I do want to do this kind of display. And I was thinking of displaying not the RMS, but displaying the gain reduction that we are applying, what we are calling the attenuation. But perhaps displaying the RMS could also be useful. I don't know, but I will take note of it. All right, so in the beginning of the stream, I mentioned that I was expecting a glitch. I didn't see the glitch. Awesome. I was really worried that I would have to go into the guts of the waveform display again to fix this glitch. So let me briefly explain what the glitch is, why I thought it would happen, and the probable reason why it didn't happen. So the glitch was all the components. So there are 4 waveform components at this point on this screen. 2 inputs, 2 outputs, 1 per channel. And the audio thread is pushing into these components, and the user interface thread is reading from these components. And there are 4 of them. And there is no notion of synchronization between the components. So it could be the case that we are in the audio thread in the middle of writing to components 2 and 3. But on the user interface thread, we are reading all of them, let's say. So in that case, we would be reading some data that has been updated along with some data that's stale. And that isn't only an issue because of the actual audio that is being captured, that it's out of sync, but also it's an issue because the circular buffers that store the information on these components, they will be out of sync. So what I was expecting, and that is the source of the issue. The visual representation of the issue, what I was expecting to see, is something that you actually see in the waveform display. This version. And if I make it stereo, then you can sort of see, if you look closely and you really pay attention, you can see them going in and out of sync ever so slightly. They will never drift apart because we are syncing this with some clever use of the sample section and the JSFX section. So the audio thread and the user interface threads are synced in a bit of a clever way that we discussed in detail in previous streams. But in any case, it's never going to drift apart for arbitrarily, but it jumps out of sync ever so slightly. You can sort of see this if you really pay attention. Maybe not on YouTube, but you can go to REAPER and run this yourself on your computer. It will be running at 60 Hertz instead of 25 frames per second, so you'll definitely be able to see it. So I was expecting this to show up here as the light gray on the background and the white to go out of sync like this, and it would glitch ever so slightly and it wouldn't look too good. Luckily, it doesn't occur. You cannot see it that way. I guess it's because there's too much information going on. Whatever the case may be, it is looking fine to me. I don't see any sort of desynchronization issues between waveform displays. Great, because that means that the waveform displays can continue to be independent of each other. The potential solution for this potential problem would have been to synchronize all the waveform displays by having some external entity that would know by how much to advance the circular buffers, and then you would need to have this orchestrator being aware of all the waveform displays And this orchestrator could be as simple as just looking at the clock and seeing how many samples have passed, and then freezing the clock for the duration of the JSFX section. If that makes sense to you, it's just stopping the clock and not reading data that is coming in real time. It's just reading data that has come in at a given point. So that could be the simple synchronization mechanism. But luckily, we don't have to deal with any of that because there is no visual glitch that I can see. So if I cannot see it, I don't have to deal with it. Great. So what's up next? Well, we want to do another component that is just like the waveform display component, but it's for a single line graph. And that's what we are going to use to draw attenuation, just like this. Let's go ahead and do it. Unlike the waveform display, I expect this to be super simple. I expect this to take only about 10 minutes to implement because we are going to take the waveform display and we are going to copy and paste and we are going to simplify it to hold a single value instead of holding maximums and minimums. We could also probably have a notion of rectified peaks, which amounts to the same because a rectified peak is a single piece of data per column. But let's just copy and paste the waveform display and start adapting stuff. We already did the hard work, so line graphs are going to be easy, right? Sure hope so. Where it says maximum and minimum, well, first of all, where it says waveform will change to line graph. Or maybe even graphs line. I don't know, we'll see. I don't know if you noticed, but I changed every occurrence, so that's a bit heavy-handed. We need to now come here and discard some changes. It's perhaps a roundabout way of doing this. Perhaps I could have searched and replaced in a region. I tend never to do that. Now, everywhere where it says waveform, I will change this to be, I was going to say graph.line, but not really, maybe just line, but then it's going to clash with some other concept in this implementation, which is the lines concept. So I guess I'm going to take it back and rename graphs line to line graph. Then waveform can turn into line graph. Again, I will do this silly thing of reversing changes everywhere else in the file. Oh, didn't work this time. There you go. So where you read the notion of maximum and minimum, that's incorrect because maximum and minimum is for a waveform. A line graph has a single piece of data at any given column. So we can get rid of the maximum and that, just like that. And we can get rid of this, just like this. And this line graph is going to do the same thing that the waveform display does, which is to decimate the inputs. So if there are like 40,000 inputs per second, we are going to be plotting 500 pixels. We'll be taking 48,000 and decimating it down to 500. Same story, same algorithm, same everything. We're just adapting it. And I guess this notion of line and lines, they used to be the lines of a waveform display, but now this is like a point. So I'll probably want to rename this concept. Let's do that real quick. Hang on, I don't think this looks right. Yeah, I renamed in a single location instead of renaming every occurrence. Let's revert and try again. I guess I will start with the renaming of the concept of lines. So instead of line graphs, let's call this bananas. And then I will replace line with point. And then I will rename bananas to line graph. Why is that? Well, just because line occurred here and I didn't want to differentiate. So I did it this way. And then we revert the changes that we don't need. Everything from the beginning. Oh, come on. I cannot find the separating point anymore. Everything from the beginning down to this point, and I cannot find the point. Here, down to this point. Revert everything that happened there. Yeah, and then I renamed the concept of point, the concept of line into point. We don't want to do that everywhere, do we? Because JSFX line is to JSFX line. So let's go over everything a bit more carefully this time. Yeah, I want to keep JSFX line. I think it will actually be a square. We'll see. Pointer 2dB, linear 2dB. Oh, the whole notion of grids. We may want to keep that notion of grids, but the notion of grids this time is harder because a waveform display is always time against volume or amplitude. It's always time against amplitude, but the notion of a line graph is abstract. So a grid doesn't really make sense. You would have to draw the grid yourself. Yeah. Well, we'll get there when we get there. My 10 minutes are running out. I don't think I will be able to do this in 10 minutes. But it will be simpler, that's for sure. Simpler than the 105 streams it took me to do the waveform display. So now I'm getting rid of the maximum versus minimum. Let's see what that looks like. Looks good to me. And Juan Carlos is here. Hello. Good morning? But it's already 7:19 p.m. See? It's not morning. Good morning. Thanks for joining us, Juan. I hope you enjoyed this one. It's kind of fun. This doesn't change. It is the number of points we want to store, so the maximum width of the component. Then this can go away, and that can go away. And then the point oh no, it's not gonna be simple, is it? Remember how I said that we want to do decimation? Let's go over this again. You are putting data into this line graph. I guess you were putting data into the waveform display. You are putting samples of audio into the waveform display. You don't want to store all the samples that you put in. You just want to store the maximum and the minimum to be able to draw. um, to draw a column of the waveform display. Great. So you have just the maximum and the minimum. But for a line graph, how do you want to store this? Do you want to take the maximum, the minimum, the average? It depends on the application. So we probably need different notions of accumulation. Yikes. Well, let's think about the notion of accumulation that we want for attenuation. I probably want to take the, I'm going to say the maximum, probably the average also works well. Let's do the average for now. So to initialize things, I put a 0 here because we are taking the average. That's unfortunate. This whole notion of different ways of accumulating stuff will complicate everything. Oh well. Yes, different time zones for sure. Yeah, I am studying Max focused on DSP, digital signal processing, ATM at the moment. But this insight helps a lot. By the way, I did catch you live. Sorry if I go off topic. Is there a way to display a simple gain on the mixer control panel? I like to have them clear at sight for teaching gain structure. I haven't found one in Reaper, thanks. Well, a simple gain on the mixer control panel. Yes, I can think of some. Well, first of all, if you want to see the waveform on the mixer control panel, then sure, we have worked on that. You can just go ahead and, there is a problem with the library right now because I'm in the middle of changing stuff, so the code doesn't really run. But hang on. I can put my, my published version. So if this is what you want to show the waveform, then yeah, sure, just put that on the MCP. We developed that together here on the stream, and here it is. But if you want just the notion of gain, then it depends on how you want to do it. Some people like to have, what is it called? A VU meter, but I have one that I can recommend. It is the Xenomod VU meter. And I like this one because it looks okay. It's calibrated out of the box with minus 18 dB as 0, but you can change that if you want. And what I really like is that it also has a volume control. So what I tend to do when I'm doing things like mixing is I tend to put the VU meter as the first effect on the track, and then you can click and drag here to add gain. So I guess I should do it on this one that has some signal going through. So when I am adding gain right here, you can just prepare the track for processing very easily. I can show you a complete example of what this looks like if I put an effects chain that is the voice-over effects chain you're listening to right now. So it looks like this, and if you have lots of these ones across your project, I think it looks okay, and it gives you a good indication of levels. And as you can see, I am experimenting with buying into the concept of putting stuff on the MCP, so you can see that all my plugins that have MCP components are here on the MCP just like that. Okay, so there is that. But when I was looking into options and I finally landed on the Xenomod VU meter, I remember seeing one that may do what you want. I think it's this one. Yeah, I think it's this one. Let's put some signal through. Yeah, I think that this is the one you may want if you just want levels like this. And this is a peak meter, so it's more in line with these kinds of meters here. And you can control stuff, okay, but the whole point is that you put this on the MCP and then it looks like that. So there you go. If you prefer VU meters, if you are using analog emulation and that kind of thing, you may prefer this one. This one you cannot click and drag to set the gain, so it doesn't help with that. You would need another volume plugin. But if you're more into the digital kind of things, then this is the one I can recommend. Maybe we will get to actually developing one of these, because I think that doing a VU meter could be fun to do the calculation of, I bumped into the microphone, sorry. To do the calculation of the little needle and the angle that it needs to have. Looks kind of fun. Though the computation of what is the loudness is something that I think is just based on RMS on this implementation. So it's relatively straightforward. We already have it. It's part of the Automixer even. But the angle of the needle seems like a fun thing to implement. It would need to do some trigonometry, which is always fun. All right. Oh, but I'm not talking about metering. I'm talking about an actual knob or fader to increase and decrease gain. Oh, okay, so you just want gain. I don't think I have one to recommend that does exactly that. But yeah, hey, let's build one. Why not? We would need to smooth the value of the gain in case you want to automate that, and we would need a knob. Yeah, let's do it. Yeah. You know what? Let's take a break from the Automixer and do it tomorrow. Why not? Yeah, that will make you happy probably, hopefully. So yeah, tune in tomorrow and we'll be doing a one knob gain on the MCP. And that's what's up tomorrow. But let's continue with this. The line graph. So to reset the line graph, there is the points maximum and minimum. Well, no longer. Now there is only points. Just like that. And to push, it's not really pushing a sample. It is more like pushing data. I guess I would call it value because the plural of value is values and the plural of datum is data. So I will call it value. So I will just rename everything value, just like that. And then again, let's remove the changes from places we don't want to change. Let's see what we have. Okay, so far so good. So we are pushing a value into the line graph. Point maximum becomes just point. Point minimum goes away. Points maximum turns into points. And points minimum goes away. Now let's find every occurrence of minimum, because we probably want to remove them, but we want to be smart about how we do it. Or maybe not. Just removing all of them was easy enough. Was good enough, I mean. And this is the point where I need to be smart about how I do this accumulation. I really wish JSFX had some notion of higher order functions, so I could just pass a function as an argument. And then the function would say how to accumulate a point into, how to accumulate a value into a point. But hey, here we are. So we are taking the average. Yeah, we're taking the average. So I will just add the value to the point. And then when pushing, I will take the point and divide by the number of values in a point, which is values per point. And that's the average. And then we are initializing the point to 0 again, instead of minus infinity. Looks about right. Let's see what you all have to say. Oh, you are welcome. It will be fun. And since we had this component that you can click and drag, I was thinking that we also needed a knob. So it's a natural progression. And I guess since it's going to be simply a gain thing, it's at least to begin with, it will be simply a little box on the MCP with gain. So let's not draw a knob. Let's just have a number and you click and drag to change the number in pretty much the same way you click and drag to change this and you click and drag to change that. This little number, that number will be all there is to it. And this will be using this notion of clicking and dragging. It will be as simple as that. I think we'll be able to finish this tomorrow. It should be so simple. I always say that. It's never simple. Okay, so for the line graph, we want to have x and y, width and height, the notion of zoom, the notion of duration, the notion of square root doesn't make sense anymore. The notion of drawing things vertically still makes sense. The notion of filling and grid, well, not really. It's not a fill. It is going to be a stroke in this case, but I will just call it, or maybe we could fill everything below the line, more in line with like rectified peaks. And I think that relimit does it on the gain reduction thing. Let's find an instance of relimit that is running on my voice and put some gain reduction going. No, it's just a line graph, no filling either below or above. So let's not fill stuff. Let's just have a color and an opacity like this. But we probably want the notion of line thickness. And we have implemented this already, but it's kind of annoying to have to use it. But I think I know how we can do it. Yeah, so I will have color, thickness, or no, width is already taken. I'll go with thickness for now. We have a notion of stroke width. Yeah, so call it stroke width. And I'll call color stroke color, and I will call opacity stroke opacity, just like that. So now let's again remove changes from parts of the code that we don't want to change, which is everything down to this point. And let's see what we end up with. That doesn't have to change. And neither does that. All right. Now let's find occurrences of minimum, because most of them need to go away. Oh, and we have that whole notion of cross and main because of the vertical. Oh, I hate that. I love the way it looks. I hate the implementation. And do we need this point cross minimum? I don't think so. I think we just want point cross. The notion of square root is gone, so that can go away. And let's continue finding occurrences of minimum. It was mostly copy and paste. This we'll have to think a bit to figure out, so I'll skip it and return. And this is starting the grid, which we don't have anymore on this version. So we can skip all of the grid stuff. Like that. Oh, this is so short. This is great. Everything that has to do with grid goes away. And let's check that all the local variables I declared actually exist in the code. And occurrences of minimum are only here where we have to think about what we are going to do. So that's okay. Then let's check the local variables. Points, main length, cross length, point main. Oh, the whole notion of main and cross isn't really needed because we don't have the notion of cross height, for instance. Yeah, we may be able to get this even simpler. Let's take this one step at a time. Offset point cross. That's still a thing. I guess if that's still a thing, all four of them are still a thing, and duration values and values per point. All of those still exist. Okay. Now let's actually read the implementation here right after we commit. Points, vertical, that seems okay. Point main. Yeah, because we are going, let's think about this on the horizontal way. We are going from right to left, so that's the point main starting at 0, offset of -1. All of that looks good. Then the main length. Okay, zoom. Clip. And then the notion of cross length. Okay, that's the height of the whole component. That's still a thing. That makes sense. Right, and then are we horizontal? If so, my X position is the main length minus the point main. That makes sense. The Y position is the point cross minus, I want to say half of the stroke width. See what I'm doing here? Then the end in the Y, the end in the X position is the same as this one, that's right. And the Y will be the point cross plus half of the stroke width. See, that's how I implement stroke width in this case, because we are guaranteed to have a line. So instead of doing lots of complicated things, I would just draw little line segments that are half of the width. And then it shouldn't be GFX point. Do we have more occurrences of this? No, but it should be GFX line. This is my search and replace going, going crazy. Okay, let's think about the vertical case now for a moment. In that case, we are drawing from top down. My X position, I want to be my point cross minus that, just like this. My main start will be point main. I think. Then that is the same for the end, because I want the line to be horizontal, so the Y positions of both the start and the end are the same. That sounds about right. So I think that the only thing I need to do is to add half to this, and I would just leave myself a to-do here. But I'm not going to do it now. I'm not going to test vertical now. I think I did the right thing, but let's just do horizontal for now. We still have to adapt the code to use this. Bumped into the microphone again. Perhaps I should position the microphone somewhere where my mouse isn't, because I'm using the mouse and bumping into the microphone. Okay, does this compile? That's the first question to ask. Boy, we have so much stuff going on. Let's remove some of it. It does not compile. Line 2465. Milliseconds to samples. That's what's up. Any other place? No. Hey, it compiles. Great. Now let's use this line graph situation. Oh, no. No, 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 no. Stop. Stop. Close. It's going to be similar to the waveform display. And we don't need one per channel, because the attenuation is the same for all channels. We don't want to change the stereo field when automixing, so there is no dual mono kind of thing. It's always linked stereo, so to speak. And this will be the attenuations. Oh, I'm on the wrong effect. Let's go to the Automixer. And attenuations is a waveform display. Well, it's not, but it is a line graph of the same length. That's crucial because I want everything to be in sync. So attenuations will be that. Then we find the place where we push at the end of the sample section, which is in this case here, and we copy and paste this much. But now we don't loop over channels, so all of this goes away. And we'll be not resetting and pushing waveforms. We will be doing that to line graphs, and this will be attenuations. What do I have here? Does that make sense? Line graph, yes. Okay. Simple enough. I am not in love with this many conditionals over the same thing. Perhaps we will collapse this stuff. But for now, it will be like this. Then, when drawing the waveform, after drawing everything, all the waveforms. Oh, we don't even need to do this in the loop. We have a loop here because we have many waveforms, but we have only one attenuations component. So this will be line graph. This will be attenuations. Let's put this on the side, or maybe below, so we can refer to the arguments we need to pass. We need to pass the attenuations line graph component. We need to pass x and y. Well, let's just have x as that, and this will be, who cares, the whole window. Oh, no, that's x and y. So I'll be drawing this line graph on top of all the waveforms together, all of them at once. Then this can be the whole window. Scale of 100%. This is the duration. Do I want vertical? No. And for the stroke color, let's go with a red of 500, very bright. The stroke width can be like 4. Is that a thing? It seems to be a thing. It is a thing. And the opacity of 100. Cross your fingers. Hey, something is happening. That's good news. Let's add another Automixer, and hey, nothing is happening. That's bad news. I think I have a clue as to why that may be. But first, let's commit what we have, because at least we are compiling and we are drawing stuff on the screen. All right, of course. Well, I think that the issue here has to do with the scale. The scale. In particular, we are trying to do this line graph relatively generic. We want it to be something that you can use for different kinds of data. But then it means that it doesn't have to be a number between between -1 and 1. It used to be a number. The waveform display used to be numbers between -1 and 1, but the line graph doesn't have to be. So yeah, we probably want to pass what's the range here as arguments. But first, I will check something that I often don't remember to check, but it's super important. And that is that I don't have any stray variables, any variables that have only a single reference. That's always a mistake that makes things wrong. So if there are any variables that don't start with an underscore, because those are library variables. But if I have any variables that have only one reference, then that's a mistake. None of them. Great. Then let's look at the names to see if we have any names that belong in the library but show up here, because that's That happens when I forgot to say that a variable is local. And it seems like this is all right. So next, I want to check. Yeah, this whole clipping situation and even this computation is all about the range of values that are allowed. And attenuations are numbers between 0 and 1, not -1 and 1. So perhaps the best way to do this is to just pass as argument the range. And then let's take that in account. And then, because I'm taking that in account, the zoom is a bit tricky. To do the zoom right, what I think I need to do is to map. It doesn't look good though, but I think what I need to do is to map. Let's review how map works. You pass it a value, then a from maximum and minimum and to maximum and minimum. So it's going to scale this value. That is the point from minimum and maximum given by the user to a normalized scale of 0 and 1, which happens to be the scale of this quantity, that this kind of value, but it doesn't always be, it doesn't always look like that. So we map into that range, and the result of this, we map from the range of 0, 1 to minimum and maximum again. I think that this is the fair way of doing this scaling, but it's so awkward. This line is awkward. Well, anyway. And now for this line, it's also awkward. I don't want values centered. I want values between minimum and maximum. So I guess this generalization is something that could make sense even in the implementation of the waveform. But because of the waveform being between -1 and 1, let's not change that. But let's think about how we want to implement this formula. Point is a number between minimum and maximum. And what we would like I could normalize this value with this map and never convert it back, because I will not need it again. Yep, I can leave it normalized. So then I can clip between 0 and 1. Yeah. And perhaps I should be calling this point normalized. Where is it used? Here, there, and then not again. It's not used again. I'll call it point normalized. And I will also go where I have the map function, and I will create normalize. which is a specialization of map where the two maximum and minimum is 0 and 1 like that. Just because I think that this concept is useful enough. Oh, I deleted the multiplication by the zoom. Well, if I'm doing so many transformations to the point, why call it normalized? There you go. But now we face this formula. Point is a number between 0 and 1. I would like 0 to be the bottom and 1 to be the top. So let's start at cross length and then subtract point times cross length. Well, that's a bit silly because cross length appears twice. So let's normalize that, or let's, I guess, extract the common factor. So it becomes 1 minus point. Does that make sense? Let's think. If my point is 0, I would like it to be at the bottom, and that is cross length times 1 minus 0. That's right. And if it's 1, then this is 1 minus 1, which is 0, so it's at the top. Yeah, that's correct. That's exactly what I want. But this whole dividing by 2 situation, does that still make sense? Oh yeah, it does, because it has to do with the stroke width. Okay. We'll see. So at least it's at the bottom, which is correct. And then, oh, hang on, is it correct? No, attenuation is not 0. Attenuation at this point should be 1. It should be at the top. Did I remember to push the attenuations into stuff? Yeah, that's not right. I am not pushing the attenuation, I'm pushing samples. Attenuation. That's right, attenuation. Why? Is it not called attenuation? It's called gain. God damn it. Replace attenuation with gain. I was pushing a bunch of zeros into the line graph. That's why it was showing a bunch of zeros in the line graph. Would you imagine that? Yeah, that looks correct. Oh, save all and commit. And try again. No, it's still at the bottom. That's no good. And if I have another one, yeah, it doesn't react to anything. So, not really working. But hey, we found one problem. Oh, gains outputs. That's not the right place to push stuff into gains.outputs. Okay, those are the only 2 instances. So get rid of that. And try again. And it's still at the bottom, so I'm still not pushing stuff. Now let's try 2 instances. Nope, not working. Oh, it's not gains of channel. Are there other occurrences? No. So it's just gains. Oh, this is so simple that it now fits in a single line. Isn't the world great when you don't have multiple channels? Well, it's very mono, but it's great. Okay, now it is at the top. And if I have 2 instances, then it's writing. Yeah, that's what I'm talking about. Does it look great? No. When it's doing the verticals jump, it does not look great. So instead of doing lines, let's do squares. But hey, it is doing something great. And it does write the gain all right. Yeah, it looks like the kind of line graph you would have for automation on the REAPER timeline. So if you were doing automation, you would have a line that jumps up and down like this. Awesome. What does it look like on the sine wave? Yeah, it sticks to the top because more gain is allocated to it. That's what I'm talking about. Let's put both of them in the MCP. And this is how I think the plugin should be used. If you're doing editing or mixing live, mixing in a live context with these kinds of graphs, beautiful. Beautiful. All right, let's adjust a couple things. First of all, I don't like this stroke width. It's too wide. Let's do 2. Is that a thing? Yes, it is. Next, I don't like the idea of the lines. So let's find the implementation of this. Instead of line, let's use rect. Is that how you do it? Yes. Or is it? Yes. Is this going to work? I don't think so, but let's try. I think we're going to see the edges of the squares. Hello. Yep, you see the edges of the squares on the rise. So next what we have is the Bezier stuff. The Bezier stuff doesn't have stroke width. Yes, it does have. It does have stroke width. We are good. So we need to go from these are the coordinates. No, these are not the right coordinates, are they? We don't want to take in account the stroke width here anymore. And didn't we have a to-do to test the vertical stuff? Yes, we have a to-do to test the vertical stuff. So, I don't know, it stands a chance of being right, but we need to change from this into that, and the stroke width now looks like this. There you go. I think that this is right. Nope, it's not drawing anything. Yikes. You know what? I'm not really sure what could be wrong here. Oh, it's a completely different concept. Yeah, this whole calculation of points here doesn't really make sense when drawing the Bezier curve. What I need is the previous point and the current point. That's what I need. So it's a completely different way of going about this. So you know what? I'm not going to commit this much. I'm going to commit this part, which is easy enough, but I'm not going to commit this because it is just completely off. That's not how we use the Bezier stuff. So what I'm going to do is I'm going to copy this. I'm going to revert. I'm going to commit that one. And I'm going to paste this here, but I'm going to comment it out. So we have this as a reference when we return to this. And I will leave a to-do of fix stroke width. Let's appreciate the thing working one last time and then say goodbye because it is time to go. And I will want to show this on the MCP because that's the way that I see stuff. That's the way I imagined it in my head. Looking pretty good. All right, so let's commit this, which is just a bunch of comments. Let's find where you all are. Yeah, so thank you, Juan and Dale and Bo and Ben for being here with me on the chat. Thank you to everyone else who's watching this either now or in the future. I see you back here tomorrow for the implementation that Juan asked for, a little plugin that lives on the MCP that just does gain. It's a simple gain knob. You click and drag it up and down. And it's something that most, or some, not gonna say most, but some digital audio workstations have this notion of trim that is above the effects chain. So our effect is going to fix the fact that Reaper doesn't have that. Simple enough. All right, I see you back here tomorrow. I hope you have a nice rest of your day. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.